Okay, so let's move on now to question number 4. So, velocity equals frequency times wavelength. What is the frequency of microwave radiation with a wavelength equal to 3 centimeters? So we must convert that to meters. So that's 0.3 meters. So you could have written 3 times 10 to the negative 2 meters, and that's equivalent to that. But I'll just put it in meters like in this notation. We know that the velocity of microwave radiation is the same as all other electromagnetic radiation. That's 3 times 10 to the 8 meters per second. It's asked us what's the frequency. So frequency equals velocity divided by wavelength. I fit those into my formula and I end up with 3 times 10 to the 8 meters per second divided by 0.03, which is equal to 1 times 10 to the 10 hertz, okay? Or simply 10 to the power of 10 hertz. Okay? What I can do is then I can write, for example, because 10 to the power of 9 is equal to giga, I can write that this is equal to 100, or 10 times 10 to the 9 hertz, which is equal to 10 gigahertz. Okay, and then I'm using that notation that I should be using. Okay. All right. Question number 5 says water waves hit a sandbank at 0.45 meters per second. So velocity equals frequency times wavelength. The velocity is 0.45 meters per second, and are estimated to be 9 meters apart. So what is the frequency of the water waves? So frequency equals velocity divided by wavelength. Let's start a new page. So frequency equals 0.45 divided by 9, which is equal to 0.5, I think. 0.05 hertz. Now, frequency equals 1 on period, or rather period equals 1 on frequency. So 1 divided by 0.05 is equal to 20 seconds. That is 20 seconds per wave. That's the answer to question number 5. Question number 6. Sound waves, so always velocity equals frequency times wavelength. Straight away it says sound waves, so I know the velocity equals 340 meters per second. Sound waves have frequencies between 30 hertz and 30,000 hertz. So frequency equals either 30 hertz or frequency 1 or 30,000 hertz. Can be heard by the human ear. What range of wavelengths can humans hear? So let's find out what is the wavelength for these waves and what is the wavelength for these waves. So wavelength equals velocity divided by frequency. I'm just going to do frequency 1 for the first one, equals 340 divided by 30. Divided by 30 is equal to 11.3 meters. Okay. For the second one, so let's just call that wavelength 1. That's the lower range. Wavelength 2 is equal to velocity divided by the second frequency. So 340 meters divided by 30,000 this time equals 340 divided by 30,000 equals 0.0113 meters. So the wavelength range for humans is equal to 0.0113 meters to 11.3 meters. So we can hear waves, if they've got a wavelength that's greater than 0.01 meters, or like 1 centimeter, or waves have got a wavelength around 11.3 meters. That's our limit when it comes to hearing. Question number 7. Radio station Nova 96.9 has a frequency, the velocity is frequency times wavelength. I know the velocity of these types of waves, radio waves, are 3 times 10 to the 8 meters per second. And the frequency that Nova produces is 96.9 megahertz. Megahertz is times 10 to the 6. Okay. If the speed of the radio waves is the same as all electromagnetic radiation, what is its wavelength? So rearranging this equation here, wavelength equals velocity divided by frequency equals 3 times 10 to the 8, all divided by 96.9 times 10 to the 6 hertz. If I substitute that into my formula, 3 times 10 power of 8 divided by 96.9 times 10 power of 6, I end up with 3.096 or 3.10 meters. So when you're listening to the radio, you're tuning your radio station into electromagnetic waves of a wavelength of 3.10 meters if you're listening to Nova. All right, question number 8. Question number 8. Velocity equals frequency